I did tell you that this class is called College Algebra and Modeling. And well, in this class, modeling just is another way to say word problems, right? So basically, this whole section is kind of like the word problem part of this class. I did say that this class was kind of created for the business school here. Basically, the business professors like don't want to teach like math concepts to the students, but they kind of want them to like I don't know. They want you to know how to solve like basic word problems with business applications. So that's why this is basically all business related instead of just like any application. So we did a couple of businessy questions in the beginning, and then I kind of described to you a couple of different terms that I'm going to be using throughout the rest of the class, in particular cost and revenue. So let's just say we have a business, right? This house. Oh, do you need one? All right. Is there anyone else who needs another one? All right. I usually like I try to like leave like a little space of time before jumping into the class, but I think I forgot to do that this time. Okay, let's just say this house is your business, right? If you're a business owner, you're either going to spend money or you're going to get money, right? If you are spending money for your business, that money is going out of your business. So it's a cost, right? And if you're getting money, it means that people are paying you, and that's your revenue, right? Now, with cost, there's actually two types of costs, right? There's fixed costs that don't depend on what you sell, so or how much you sell, right? So, for example, the rent for your office, right? That doesn't depend on how much of the product that you're selling. So, rent would be a fixed cost. The amount of money that you spend to make someone sit in your office for 5 hours, that's a fixed cost because that doesn't depend on how much that you're producing, right? Now, variable costs, on the other hand, actually do depend on what you are selling or how much that you sell. So, for example, if you had a lemonade stand, the amount of lemons that you use is a variable cost, right? So the cost of a lemon, if you produce a lot of lemonade and you sell a lot of lemonade, then you're going to buy a lot of lemons. If you don't sell that much lemonade, you're not going to buy that many lemons, right? Okay, so we have a couple functions that I told you. You either had to like memorize or at least like know how to create. Our cost function talks about all the costs or the things that we're spending on. Variable cost is the slope because it is attached to the variable. The fixed cost is the y-intercept because it's fixed and it's by itself. Okay. The revenue function is all the money that you are gaining. So basically, that just means, okay, we need to take the price of each item, multiply it by how much we sell, and then that's how much money that we make. Okay. And then finally, we have the profit function, which is kind of like the combination of the money that we get and the money that we spend. If we make a positive profit, it means that, okay, we're getting a lot of money and it's overpowering how much we're spending. If we have a negative profit, that means we're not doing that good because we're spending too much and we're not getting that much in. Okay. Finally, we have this thing called the break-even point, and that's basically when the revenue is the same as the cost, so you're not making any profit. There's two ways you can find that point. You can either set the cost equal to the revenue, or you can set the profit equal to 0. Okay. So we did a couple examples, right? In example 3, I kind of just laid out everything and we found those functions, found the break-even point. And then I kind of let you stew on example 4. We didn't go over it yet, but I did let you try it first. And because, well, it's been a while since Friday, let's kind of just go through this together so we all are on the same page, even though you have done some of this before. And then we'll do something a little different. Okay, so for example 4, we have our fixed cost, our variable cost, and our price. Part E, I guess, is asking us to find the linear cost function, which is C of x, right? Okay, so remember, C of x has a slope and a y-intercept, and C of x only deals with cost, right? So these two are the cost. Those are the only two numbers that are going in our cost function, definitely not the price. Which one do you think is going to be my slope? The variable cost, right? Because the slope is attached to our variable x, right? So this becomes 0.4x. And then I guess the other cost is the 5625, which is added on as a constant. Okay. So that's my C of x. Let's do R of x. R of x is the revenue, or how much that I'm getting, how much people are paying me. And that, just by common sense, is the price times how much I sell, right? So I guess the price is 1.3. How much I sell is x. And well, R of x is pretty easy, right? Finally, let's do the profit function. P of X, okay? Does anyone remember the equation for the profit function? Perfect, R of X minus C of X, okay? And we can do that easily by doing 1.3x, which is R of X, and subtracting off C of X, which is 0.4x, plus, I was just about to say that. Don't forget the parentheses, right? Whenever you're subtracting, I do it every time. But when you're subtracting off a whole thing, you definitely have to put parentheses around it, or else you're gonna miss a minus sign, right? What do I do with our parentheses? Distribute the -1, right? So we're gonna take that -1, bring it to the minus 0.4x and the 5625. And then I guess we can collect like terms. Hopefully we all got 0.9x minus 5625. Okay. So any questions on creating C, R, or P? Sounds good. Finally, we need to determine the break-even point. Now there's two ways we can go about doing it. Does anyone have a preference? That yeah, I think we should do that. Was that what you're gonna say too, Kai? Yeah, I honestly think doing P of X equals 0 is easier. I don't know. Yep. All right, let's set P of X equal to 0, which means 0.9x minus 5625 is equal to 0. This one's a pretty easy equation to solve, right? Just add 5625 to both sides, and then that will give us 0.9x equals 5625. Perfect. Perfect, yep. X is equal to 6250. Got it. All right, are we all good with this example here? Okay, honestly, this is kind of like the harder part. We're actually going to expand this to an application where I'm not actually giving you the cost or the prices. So you're going to have to figure that out on your own, which is basically what example 5 is. So let's go ahead and take a look at example number 5. Okay, we have a summer art show. At this show, we have a vendor that sells lemonade for $2 per cup. Okay, also the cost to rent the booth is $120. Okay, and the vendor knows that if I buy lemon, sugar, and cups, that collectively costs about 50 cents per cup of lemonade that's sold. Okay, now before I go ahead and even look at this this question, I think the easiest thing to do is to just kind of figure out which is which. Okay, so we have costs and we have prices, right? I think the easiest one to start with is the price because the price is easy to determine. What do you think is the price per cup of lemonade? $2, right? So that one's pretty easy to determine. Of course, that's the price. Okay. Now, yeah, in terms of costs, yeah, probably, yeah, I would definitely not do $120 for lemonade. I don't know, maybe.
What if it made you immortal? That would be a steal.
Okay, if I turn immortal, I would have, you know, immortality is bad because if you're immortal, you also have to make sure that like you don't age because I would not want to be 300 years old and like not and like have myself age. So I'm like rotting. That's also true. I don't know. Like if I want to be immortal, I'm gonna be like Wolverine and like stay the same age. Okay. I'm not aging. Okay. All right, let's figure out the cost here. I think the easiest cost to figure out is the variable cost because that's the thing that changes based on how much we do. What do you think the variable cost is? 0.5, right? That's the variable cost. And then 120 is the fixed cost because that's just by process of elimination. Okay, so I don't know. I feel pretty confident. How about I'm going to have you do A, B, and C. I'm going to give you like, I don't know, 3 minutes. I'm going to come back up to the front. I know you guys are still working. I just like making you stew on it for a little bit. Sometimes you don't know what you don't know until you try it. And then you're like, oh, what do I do? Okay, so let's do the cost function. Did we all, I think as I walked around, we all got this. Did we all agree it's 0.5x plus 120? Good. Do we all agree that R of X is 2x or 2.00x? Cool. All right, and then finally, to get the profit function, we need to subtract r of x minus c of x, right? So that becomes 2x minus 0.5x plus 120. What'd I do wrong here? Parentheses, right? We distribute that minus to both of these guys, so this becomes 2x minus 0.5x minus 120. And then if you collect like terms, you should have gotten 1.5x minus 120. All right. Any questions on how I got r of x? Or sorry, p of x. I guess I should write that this is p of x. That would be helpful. All right. Now, what we're going to do is we're going to answer some questions that are a little bit different than what we did before. Sometimes we're just interested in not like the break-even point, but just like, okay, what's my profit if I sell like 50 cups or 100 cups or 1,000 cups? Am I going to gain money? Am I going to lose money? What's going on here, right? So this question's asking me, okay, what's my profit? And remember, profit is kind of like that combination of the money you get and the money you spend. So how much profit am I going to make if I sell 50 cups of lemonade? Yes, if I produce and sell 50 cups of lemonade. Okay, so let's just think about it. It's asking me about profit. So I definitely should be plugging something into P or doing something with P, right? Now, 50 cups of lemonade. Let's think about this. Is 50, does that represent an X value or like a Y value?
Why?
Little X. We all said Y and then we changed it to X.
I just put in for the X. So yes, it's X.
Yeah, let's take a look at the question. It literally says X cups of lemonade, right? So X is representing how much that we are selling, right? So 50 definitely has to be X, which means I'm literally plugging 50 into P, right? That's this whole question. So the way I'm going to write it is P of 50, because remember, the thing in parentheses is the thing you plug in. And let's just plug it into my equation. 1.5 times 50 minus 120. I usually show my steps here, but I'm going to be lazy. I got negative 45. Yes. Yes. Perfect. Oh, we got a negative profit. Is that okay? I mean, is it allowed? It's allowed, but it's not okay. Yeah, it's not ideal, right? A negative profit means, remember, we have our business, right? In our business, we have costs that's coming out of our business. We have revenue, which is coming out of our business or coming into our business. If we have a negative profit, it means that our cost is really big. So we're spending a lot, but we're not making a lot. Okay. So people aren't paying me enough. So that means if I sell 50 cups, this is actually bad for my company. I'm losing money by having a negative profit, right? So right now I'm losing money.
You also have to subtract the 0.5 for each cup.
We kind of already did that because the profit function is a combination of these two. So the 0.5 actually goes in here. Yeah. All right. All right. So hopefully for part E, you plugged in 128 into your equation. Did we all get 72? Yes. Cool. Now 72 is positive, which means that's a good thing for a company, right? It means that, okay, it looks like people are paying me more than I'm spending for the business, right? So this is a good thing. I'm making money here. Okay. Now, what we just did here is just by plugging in these numbers, well, I kind of know that the break-even point where my profit is 0 has to be between 50 cups, right, and 128 cups. Because when I sold 50 cups, I lost money. And when I sold 128 money, oh my God, when I sold 128 cups, I made money. So my break-even point has to be kind of in between those two numbers. Let's actually figure out what that break-even point is. Does anyone remember how to find the break-even point? There's two ways. Perfect. P of x. Yes, not P of 0, but P of x equals 0. P of x equals 0 means to set that 1.50x minus 120 equal to 0, right? I can add 120 to both sides. Okay, 1.50x is left on the left. I have 120 left on the right. And if you just divide by 1.50 on both sides, you should get that x equals 80, which means that 80 cups of lemonade is our break-even point. Okay, so what that means is, okay, if I sell less than 80 cups, I'm going to lose money. If I sell more than 80 cups, I'm going to gain money. Yeah.
You just divide just 5, 20.
Um,
Because I got the same thing.
so 1.5 over 120. You should get a decimal if you do that, I think. Yeah.
No, the other way around, it's 120
Yeah.
over.
Yeah, you could also do that. Yep. All right. Yeah. All right. So I do kind of want to talk about what this means graphically. We have talked about graphing lines and showing what they look like based on an equation. So I just want to show you like what it looks like when we graph the two lines or the three lines that we created and what it actually means in terms of the application. Okay. So we have three lines here. We have the cost, the revenue, and the profit function. Okay. The first thing I'm going to do is I'm going to graph the cost function and the revenue function together. And that's what this graph on the left is, okay? On the left, we have a blue line that represents the cost function. I also have a pink line that shows the revenue function, okay? Now, where they intersect, does anyone know what that represents? The equilibrium, okay. It's the break-even point, right? So the break-even point is like the equilibrium, I guess. And that's kind of, well, when another way to find the break-even point is to set C equal to R. So it makes sense that when they cross, that's the break-even point, right? And let's take a look at what happens to the left and to the right of the break-even point. If I take a look at the left of the break-even point or the left side of the graph, we can see that the blue graph is above the red graph, right? And that makes sense because if I'm not making as much money, the cost should be higher than the revenue, right? Now on the right of my graph, or my break-even point, now the revenue is higher than the cost. So that means after my break-even point, now I'm making more money than, well, what I'm spending. Okay, so that's kind of what the graph means if you were to graph these two lines. But I didn't show you the graph of the profit function yet. So what I'm going to do here is I'm just going to graph this profit function that we found on part C. That's the graph to the right, okay? And this profit function is by itself, okay? Now, the break-even point on a profit function is kind of shown here, okay? And what's special about this point is it's where it crosses the x-axis, okay? Because the x-axis is where the profit is equal to 0, right? So basically, it's kind of a different way to visualize the break-even point. The profit function to the left of the break-even point is negative, right? To the right of the break-even point, the profit is positive. So basically, the break-even point for the profit function is where it goes from negative over to positive. Okay. Any questions on like graphically what's going on here? I kind of wrote a description of it below. It honestly, I think my written description just doesn't make that much sense in terms of, I don't know. I think just me explaining it is easier to understand. You won't have to like write this down on a test or anything the way I did it. But you should know like, okay, like before the break even point, the cost is higher. After the break even point, the revenue's higher. And then the profit function 0 at the break even point. Okay. Any questions on these guys here? Okay. So in my last class, I showed everyone this next example, which is literally the same example as the one I just did. I don't know. I feel like you guys are good at this. I don't think we need to redo the same example again with the same numbers. Yeah, like instead of 2, we have 1.5, and I don't know. I think we'll be okay if we skip this question. It's literally the same thing. Yeah. So let's kind of just skip over example 6 because I don't know. I don't think we need to do it again. I think that'd be overkill. I thought it'd be a good idea when I made these notes, but now I'm thinking about it. I don't know. Okay. Let's take a look at example 7 instead. Okay. So even though most of this class has a business sort of theme to it, I do want to show some other examples of lines. In particular, well, I don't want to say it yet, but this application here is a healthcare application where we have a graph, okay? On the x-axis, we have the age of a person, okay? And the y-axis represents their blood pressure, okay? So what I've done here is I've done an experiment. I didn't do it, but the textbook did. They went and randomly selected 12 adults, okay? And what they did is they asked them their age. So, we have a bunch of people who have different ages. And then what they did is they found their blood pressure and they kind of plotted them up here. So what we have here is we have 12 dots, okay? And each of these dots represent a different data value, okay? And it represents a different person. So the X value represents their age and their Y value represents their blood pressure, okay? On top of these points, we have this line that's drawn over them. Does anyone know what this line is called? Line of best fit, right? So if you ever take a stats class, you'll have to learn about this thing. It's called the line of best fit. Your stats professor might call it the least squares regression line. But the line of best fit is basically a line that doesn't say exactly what's going to happen, but it is a good prediction of what will happen based on what we have already. So anything on this line doesn't represent something that happens in real life. It's mainly used as a prediction tool to be like, okay, I don't, yeah. Like I have someone who's 51 years old and I know that their blood pressure is 130, but what if I had someone who was like 50 years old? Well, I don't have a point for it, but what I can use is I can use the line to figure out, okay, what is their predicted blood pressure? Okay. So that's basically what this is about. I know, isn't that kind of cool? Yeah, actually that normally doesn't happen,
Right.
but it is nice that it happened here because now we can actually find the equation of that line of best fit, which is pretty nice. Now, usually in a stats class, you'll learn how to make that line of best fit, either using an equation or using like Excel or something like that. But let's just find it out using our slope formula. Okay, so let's say we have these 2 points on our line, okay? I want to find a linear model, basically an equation that relates y as a function of x. So basically to do this question, you're basically going to do what we did on number 1 on our quiz, right? We're going to find an equation that represents a line going through those 2 points. So let me just get you started here. The first thing you need to do is to find the slope, m, right? And remember that equation is y2 minus y1 over x2 minus x1. It doesn't really matter which one is x1 or x2. I'm just going to make 21 x1, 118 y1, x2 y2. And how about this? I'm going to give you like 2 minutes. I'm going to have you find the slope. If you want to work ahead, you can. But for now, just find the slope and then we'll come back. I will say just for this section, you can use this. I would say for this question, yeah, because it's just gonna really suck if you have this or if you have fractions. Yeah. It did. Okay. Let's go ahead and go over this real quick. Hopefully you did 130 minus 118 up top, and you did 51 minus 21 on the bottom, which got you 12 up top and 30 on the bottom. Now I'm lazy. I'm not even going to reduce this. I divided this together and got 0.4. All right. How would I go about finding the y-intercept? Pick a point and plug it in, right? So do you want to do 21? What? Do you want to do 21, 118? Oh, 51, 1. Okay, let's do that one. Oh, yeah, that's a good idea. So let's do 51, 130. 51 can be x and 130 can be y. Okay, I know that y equals mx plus b. So if 130 is y, then it goes on the left-hand side. I know that m is 0.4. I know that x is 51 and b is by itself. So let's go ahead and do 0.4 times 51, which is, let's see, 20.4.
Yes.
Good. And then if you just subtract 20.4 on both sides, let's see, we should get 109.6. All right. So altogether, our equation becomes y equals 0.4x plus 109.6.
Should y of x equals said y resolution of x? Could I do like y then?
Yeah,
X?
you can do y of x. I will say like this notation's kind of weird. A lot of people don't use that for some reason. Like usually it's f or g, but you can do y of x. That's fine.
I just that's why I really
Yeah, I guess technically, yeah. Yeah.
Or you would prefer it's y.
I don't know. I personally looking at y of x just makes me mad.
Okay.
I don't know. I don't know. I'm gonna keep it as y, but you can keep it as y of x. Okay. All right. Next. Now, whenever we have a word problem, most of the time the word problem's gonna ask you to interpret the meaning of it, which is a question that I just don't like a lot of the times because it confuses me, right? Now, whenever you're asked to interpret the slope, I have like a really easy method to figure out how to interpret it. Because just looking at our slope 0.4, it's kind of confusing. Like, what does 0.4 actually mean, right? I know it's like the change in y over the change in x, whatever.
Like 40 years.
Not quite, which is why I like doing this trick. Okay, here's the trick. If you're struggling trying to figure out what the meaning of the slope is, well, I know that slope is rise over run, right? And another way you can write any number is by putting it over 1, right? Even if it's a decimal, 0.4 over 1 is still 0.4, right? Okay. Now, I know that I have rise over run. Another way to say rise is the change in y, right? It's the change in the y values. And another way to think about run is the change in the x values, right? So change, yeah. Okay. Now,
So it's for
let's keep thinking about it. So I know that y represents the blood pressure. So instead of thinking about it y, we can say, okay, blood pressure. Okay. I know that x is the age in years, right? So that's just age in years. So I kind of like to start at the denominator, okay? Now what it's saying is if I change by 1 year, then the blood pressure is going to change by 0.4.
right.
Does that
That's
make
what I
more
was trying to
sense?
say, yeah. For
Yeah.
every year it goes up 0.4, well, and then from starting at 109.6, it goes up 0.4 every year.
Yeah, pretty much.
How would you write that?
So the way I would write this, first of all, this isn't something that always happens, right? The line of best fit is a predicted value, so it's not like an actual thing that happens. So what I would say is, as we age, 1 year, okay, we would expect our blood pressure to, are we increasing or decreasing? Increasing because it's positive, right? To increase by 0.4. Okay, that's how I would say it, right? So each year that you age, you're expecting your blood pressure to kind of go up by 0.4.
How would you implement that starting value of 109.6?
No, because this time we're just interpreting the slope, right?
Oh.
So we're not interpreting the y-intercept here. All right. Any questions on part B? All right. All right. Let's estimate the systolic blood pressure for a 55-year-old. Okay. I know that my equation, all I need to figure out is if I'm plugging 55 in for y or for x. Does 55 represent an x value or a y value?
That is your x.
It's an x value, right? Because x is the age. Are you okay, Ryan? Oh. Oh. Are you good?
Are you dying?
Oh, I'm sorry. Okay.
I'm sorry. I'm just trying to help.
All right. Oh boy. All right. Let's plug in 55 in for x. So this becomes y equals 0.4 times 55 plus 109.6. And I think 0.4 times 55 is 22 plus 109.6. And if you add that together, it should be around 131.6, I think, would be our predicted y value. Yeah.
Also get your graph, you can see like at 51, you see a 51-year-old that's at 130. And you can just time, and then you can just do 100 plus 0.4 times 4.
0.4 times 5, right? No, times 4. Sorry. Yeah. No, you're right. You got it before I did. Yeah, you could also do that. Yes. Any other questions on part C? All right. Okay, so what we're gonna do is if you flip the page to the back, we have another example. This one's talking about like television services per year. Why don't we do the same thing for example 8? I will say that part C is a little bit harder to interpret than the last example, but I think you can do it. And we'll come back.